Welcome to today's webinar From Classroom to Career, Building the Next Generation of CFD Expert, brought to you by Convergent Science. Thank you for joining us today for the 7th event of the 2025 Converge webinar series. My name is Matthias Sulis and I am part of the business development team at Convergent Science. I will be your host for today's event. I'm glad I can be here with you today and hear from my colleague Jameil Kolliyil about Convergent Science's own Academic and Explore program. Convergent Science is a rapidly growing computational fluid dynamics software company. Our flagship product, Converge, is an industry-leading CFD solver used around the globe to simulate fluid flows in complex systems. Converge features truly autonomous meshing, which eliminates all user meshing time and helps provide fast, accurate results for our client. Now it is time to introduce our speakers for today's event, Jameil Kolliyil. Jameil is an academic program manager at Convergent Science India. He leads the Converge academic program across India, Southeast Asia, and Australia, where he focuses on building strategic collaboration with universities and delivering licensing solutions tailored to academic needs. He brings a strong technical background to his role, having earned a master's degree in chemical engineering from TU Dortmund in 2020. Without any further delay, I will now pass the ball to Jameil. Thank you all.
Hi everyone. In this webinar, we'll start by talking about the Converge Academy program, what it is, what it offers, and how it's making a difference. We'll walk through its key features and benefits, and you'll also hear testimonials from a few of its current users. We'll also take a quick look at the variety of free resources available, like training and support that help our users get the most out of Converge. And finally, we'll introduce the Converge Explore program, which opens the door to skill development and learning for both students and professionals. So with that, let's jump in. Since 2008, Convergent Science has been dedicated to supporting academic research by offering exclusive licenses designed specifically for universities and educational institutions. In fact, in some regions, we even provide these licenses free of charge to help broaden the access to advanced CFD technology. Today, over 800 academic users across 200 universities around the world are using Converge, a clear sign of its impact on both research and education. Whether it's used for classroom instruction, student projects, or advanced lab research, Converge offers powerful and flexible simulation capabilities for a wide range of academic needs. That said, it's important to mention academic licenses exclude certain users. They're not intended for consulting, commercial work, or any research under NDAs. Our focus is on fostering open and collaborative academic research. So what exactly do you get with the Converge academic license? You get full commercial access, meaning every feature of the software is available to you. This lets you dive into advanced research without worrying about limitations on features and models. To make your workflow even smoother, we offer Converge Studio, a user-friendly graphical interface that simplifies setup, visualization, and simulation analysis. And here's the big time saver, our autonomous meshing. So instead of spending hours or sometimes even days creating a mesh, Converge automatically creates a high-quality mesh at runtime, even for highly complex geometries. This means that you spend more time on research and less time fiddling with mesh generation. For more advanced simulations, Converge supports multiphysics modeling, including fluid structure interaction, multiphase flows, turbulence, and conjugate heat transfer. And when it comes to modeling combustion, we have the SAGE detailed chemistry solver, which allows you to simulate combustion and chemical reactions efficiently. All of this is designed to support complex real-world research projects. So we know that having access to the right tools is only part of the equation. That's why we offer a wide range of free training courses for beginners all the way to advanced users. These trainings help ensure you can make the most of everything Converge has to offer. But beyond that, we also provide robust technical support for all our academic users. So, whether you're troubleshooting, looking for guidance on your simulation, or just have questions, our dedicated support team is here to help. And we don't stop there. You'll also have access to a growing library of tutorials, case studies, and user communities. So, you're never working in isolation. It's all about helping you grow your skills and making real progress in your research. Now, let's hear from Professor Bhaskar Tama from Mahendra University as he shares his experience teaching Converge in his class.
Hello
Thank you.
everyone. I, I am Bhaskar Thamma. I'm professor at in the Department of Mechanical and Aerospace Engineering at Mahindra University, Hyderabad, India. I worked 20 years in industry, mostly on IC engine related problems, combustion and emissions. And last 6 years, I have been with Mahindra University teaching elective courses and basic thermodynamics and IC engines. So when I started teaching IC engines, I always, since coming from industry, I always thought we need to have the theory and the state point calculations that are done in the class to be related to a practical application. So as to correlate this with the engine test. Then in the next stage, want to take it to the next level and then let the students go and visualize at the phenomena level what is happening locally inside a combustion chamber. That's where, because of my prior experience with Converge, I chose Converge. While experiments gives a cause and effect um, uh, physics, which is like you change either the load or the fuel input or the intake air, you see an output change in terms of either the emissions or performance, right? But students need to get more understanding of what happens inside the engine, and that's where Converge comes into play. So the key is why Converge, right? So undergraduate, since this course is for undergraduate students, the undergraduate students latch on to anything which is, has a good GUI, easy to use, a lot of examples that are already there, a post processor that can help visualize all the data that comes out of the CFD simulation. And of course, the final one is free to use, and it can be run on a bit of advanced laptop with at least 6 to 8 cores with reasonable RAM of 16 to 32 GB RAM, right? And Converge has this GATE program for students called the Converge Explorer, which provides free software, initial training to them, so that the startup time is minimal, so that the student can spend more time in terms of identifying a relevant example case, start running it, interrogate the system by varying the input parameters and visualizing the uh, output. How does it change, right? So last year when I offered, three of the students chose to uh, simulate using Converge. They had very great experience, and they told that since it is easy to start, they could pick a relevant example, run it, visualize it, and then that gave them a much better understanding of the physics that has been taught, right? And the theory of the phenomena that is also taught in the class, and what they have observed in experiments, and then they could correlate these simulation results with what all they have learned. So they were really happy with it, and then that sort of gave them that you learned the fundamentals, through thermodynamics, thermal engineering, fluid mechanics, advanced fluid mechanics. They do multi-physics, advanced mathematics, and it all comes together as an application, integrated application of all those theories in a IC engine simulation using software called Converge. So this sort of a tool would help students to assimilate faster, also understand the physics behind it, and what are the parameters that they can interrogate, how to make design changes based upon what they see globally and temporally. Different parameters like pressure, temperature, equivalence ratios, emission concentration within a combustion chamber, using different slices of information. So this will help them a lot in industry, because when they look at a problem, they know whether it has to be done through hand calculations or a 0D or a one-dimensional tool, or should they go into a three-dimensional full-blown simulation, and what are the advantages and limitations. Advantages in terms of the spatial resolution, so that the design can be optimized to the very closest form, and limitations in terms of how much time it takes and the computational resources that are required, right? Overall, I see integrating Converge into the IC engine has benefited the students a lot, and thanks to Converge for providing both students and me a license, so that we could both interrogate and then share the experience, so that it's a good learning experience. Thank you.
Thank you, Bhaskar. Now, please welcome Professor Davide Ziviani and his student Sritam Bhaduri. They're from Purdue. They'll talk about the goals of their funded project and how simulation fits into that.
Hello, everyone. I am Davide Ziviani. I'm an associate professor in mechanical engineering here at Purdue, and I'm also the co-director of the Center of High Performance Buildings. I've been at Purdue right now almost 10 years and almost 7 years as faculty member. My primary research is on heat pumps and thermal management systems, different applications from residential buildings to commercial buildings, industrial applications, as well as deep space habitats as well. And I think maybe just a fun fact, I think I started working with Converge team, I think even during my PhD times. I think that was the first time that I've been using the software. And then the relationship just kept going over the years. This particular project that we have been working over the last 3 years and a half, almost four, is funded through a Bechtel Corporation, and it had a couple of different research goals. One being the development of a new cycle architecture for a large-scale refrigeration system applicable to cold storage facilities, large industrial plants. And the second goal was to optimize an ejector that is used for recovery and expansion work in those systems to limit the power consumption from the compressor. And a couple of additional aspects of the project were to really push the boundaries as far as design optimization and employing 3D printing and additive manufacturing to get the prototype done. And therefore, we needed a high fidelity tool that will allow us to run complex 3D CFD simulation in transient and capture the interfaces between the phases, boundary layers, different turbulence occurring, and ultimately with the results from those high fidelity simulation, getting to reduce all the models for exploit larger design space. I had personally a long relationship with Convergent Science, and obviously I used the software for several years now. But besides the need for a software tool, right, there are many out there, but I think as we were investigating kind of new geometries and new physics as well within the ejector, we needed to have a partnership that will allow us to actually implement new models or maybe tweak existing models already coded into the software, and even getting technical support on how to expand existing models. And therefore, conventional softwares were feeling very tight on this, and we needed really the direct support from the technical team to really engage at the software coding level. And this was not possible without the software platforms, and therefore we really value the collaboration directly with the technical team over the last few years.
So I'm Sritam. So I'm a PhD student under Professor Siviani here and Professor Kroll at Purdue, and I do research in ejector. Basically, my PhD thesis is on ejector. So I'm working on with Convergent Science since 2019. It started from back in India during my master's degree. So here I can tell you that, as Professor Ziviani mentioned, what are all the advantages, and from the user's perspective or from the student perspective, how Converge actually support and shape our work. And that's basically Converge. I can say that Converge is a good tool for turbulence, multi-phase partial resolved scale simulations, which is pretty much it happens inside a ejector. And Converge really provide some good control over various model parameters which we are going to use it, and also adapt custom material properties from NIST, right? Which is very much required for simulating a transcortical CO2 type of ejector, which used in refrigeration systems. And to model all these things, we need some advanced multi-phase modeling physics, right, to be involved, and which Converge provide us. We independently also verified the order of convergence of Converge solver, and it provided like second order convergence with a larger dissimulation, which is very much required, and it's also never gave us the over dissipation effect. It perfectly captured the Kolmogorov energy spectra, like k power minus 5/3 law, and which is basically as a result of the solver, and also basically the unique grid the mesh generation process, which also apply that adaptive mesh refinement, region-based refinement, etc. So simulation tools, if you talk about like Converge is a good tool for simulation, CFD simulation, but I must emphasize here that research is just not about running a software or running a code and obtaining some result, but rather understanding the underlying logic of the code, which is based on the physical principles and modeling assumptions. Therefore, understanding the theory and governing equation of individual model, what we implement in our models, in our code, and as well as understanding the stability criteria for the numerical methods implemented in the code is essential. And Converge documentation enables all of these things, these advantages. It documents individual models, governing equation, stability criteria, pretty good way. And furthermore, I can tell that the technical team, as Professor Ziviani also mentioned, this emphasize on the same thing, that the technical team is pretty collaborative. They help us a lot, and they are very agile. And of course, I got this help not only from in my PhD, but started from my master's degree. So yeah.
Yeah, in our research endeavors, the requirements are very diverse. There are several problems requiring high fidelity simulations at different scales, different geometries, and different physics that needs to be resolved. However, I will say that understanding what type of models are needed for the specific research questions that needs to be answered. I think that's always the first step, because then you can dive into the details of software requirements, whether it's Converge or something else, but then you can narrow down really what do you need. Uh, but then within a research proposal, it's also important to engage the software team, as we did with Convergent Science, to understand the openness of working through bugs and model expansions and additions to the software that maybe are needed for a particular problem. And so for me, when I was applying for grants, we had big vision on what was required, but we had the great support from the technical team to understand really what can be done. And in certain situations, like in this ejector, we actually we needed to add patches to the software that were ultimately released, I think, in some of the distributions, because we were missing modeling pieces. And so I think that's very important to have that conversation with software developers, and try to understand if there is room for development. So anyway, and then from my side, yeah, obviously having a dedicated university partnership office or team that you can engage with, that they're open to working with universities on research problems and fostering education, that was also pretty essential for us. So that was very successful.
Thank you, Davide and Sritam. All right, now let's talk about something relatively new, the Converge Explore program. This is our newest free licensing option, created specifically for those who are just getting started with CFD. So participants of this program receive a 1-year renewable license with access to all commercial features, with a simulation cap at 1 million cells. This limit allows users to explore a wide range of simulation topics while learning advanced CFD techniques. If you're wondering whether this program is a right fit for you, please reach out to us. We'd be happy to talk and find the best licensing path for your needs. Now let's hear from one of our Explore users, Isuru Vikramachai.
So I'm currently completing a research-based master's degree in mechanical engineering at University of Maroto, Sri Lanka. My research focuses on hydrogen fuel internal combustion engines, specifically on optimizing engine parameters to improve performance, reduce emissions, and prevent abnormal combustion. So before that, I completed my bachelor's degree in mechanical engineering from the same university, where I first developed an interest in engine simulation. I'll soon be starting my PhD, where I will be working on ammonia spray modeling, continuing my focus on clean combustion. And along the way, Converge Explorer program has played a huge role in shaping my journey. When I first came across the Converge Explorer program, I had just begun my undergraduate project. So I was diving into research on hydrogen internal combustion engines, and I needed a simulation tool that could keep up with the complexity of modern engine modeling. So that's when Converge immediately caught my attention. So what made Converge stand out was its real-time meshing, its capability of handling moving boundaries, and its powerful combustion modeling features. But what truly made it accessible to me was the Explorer program. It turned the door for the students like me to use an industrial leading CFD tool along with expert training and dedicated support, all at no cost. So at the time, my knowledge of combustion modeling was pretty limited. So, but the training program provided through the Explorer program was incredibly well structured. So it walked me through everything with hands-on tutorial cases that showed how different modeling strategies could be applied to the same problem. So that level of insight helped me to make informed decisions for my own project as well. And anytime I faced a challenge, the Converge support engineers were there. They were quick to respond and incredibly helpful, which really accelerated my learning and gave me the confidence to work independently. Thanks to this support, I was able to complete my my final year project successfully, generate publishable results, and even present my work at the Converge user conference. That experience was a major milestone. It gave me a platform to share my research, build connections, and see how Converge is being used to solve real-world problems all around the world. The lasting impact that Converge Explore program had on my growth, when talking about that, the Converge Explore program has been a defining part of my journey, not just technically, but personally as well. I've always been passionate about safety and combustion, but like many students, I wasn't sure where to start or how to turn that passion into something impactful. So the Explore program provided that roadmap, the training, the mentorship from engineers, and the access of the advanced tools and the opportunity to present at international platforms. All of it helped to develop not only my skills, but also my confidence. That foundation has led me new opportunities as well. I'll soon be starting my PhD focused on ammonia spray modeling, another exciting area in clean combustion research. I'll be continuing to use Converge for that work as well, building on the same expertise I developed through the Explorer program. More broadly, experience from the Explorer program helped me to define my long-term vision. I'm especially passionate about bringing together the simulation and AI to develop cleaner and optimized engines. The Explorer program gave me the technical foundation and early exposure to this pursue this direction.
At Convergent Science, we believe that academic research drives innovation. That's why we work closely with universities, not just as software providers, but as partners invested in their success. We love celebrating the work our academic users are doing, and we regularly highlight academic research that's pushing boundaries in science and engineering. Our tools and support are designed to help researchers push boundaries, tackle complex challenges, and ultimately drive forward the future of engineering and science. This commitment is reflected in everything we do, from personalized support to ensuring that Converge evolves to meet the unique needs of the academic community. Thank you all for being part of this webinar. And if you have any questions, please reach out to us.